Hello, and welcome to another Appfarm Developer Forum webinar. Today, we're going to discuss the process of optimizing performance in Create. So maybe anyone watching this video now has an app or a service or even a specific action which takes a very long time to run or perform, and you're wondering how this process can be improved. So that's what we're going to discuss in the webinar today. Part 1, we will discuss everything that happens when you load an app, when you click the icon on your phone, or when you type in the URL on your computer, everything that happens between when you press enter and when the first view is shown to the user. There's a lot of steps in this process, and there's a lot of areas where it can be improved if you're noticing that your apps are taking a long time to load. And then part 2, we're going to discuss specific user interactions which can cause bad performance. Maybe it's an updating of an object, creating of an object, selecting an object, deleting an object. There's a lot of potential for refiltering of data, recalculating of properties based on these updates if potentially there's a setup that can be improved. So we're going to discuss that in more detail. And then to finish off, we're going to discuss features that are available in Create to help with optimizing performance. So, to start, how does Appfarm actually load and process data when the app is loaded for the very first time? So the first step that happens is that you populate your data sources. Every single database connected data source is returned in a single batch from the server. If you have 50 database connected data sources with 5,000 objects in each source, then this is going to suddenly become a very, very big batch which is returned from the server. So this can cause delays if there's a lot of database connected data. It's impacted primarily by the number of records. The more records, the longer time it takes. Filter dependencies can also affect this process. If you have a database connected data source which is reliant in its filtering on another database connected data source, then this first data source needs to be populated before the second one can be populated. So there's a reliance there, some dependencies there, which can cause imperformant reading of data. And then the number of columns can also have an impact in this case. So now we'll look at some specific cases and how in each case the performance is based on the setup. So in this case, we have a request which is just one data source which has 30,000 objects in it. There's no data bindings, there's no filter dependencies, there's nothing, it's just one data source. And we can see from the logs here, 30,000 objects takes 2.1 seconds to load. In a second case, we have the same large data source, 30,000 objects, but it's got two deep data bindings in it. You can see you collect company name from taxi company, and you collect the model name from the vehicle type from the taxi, which is connected to the taxi trips data source. So you can see from the logs when the request was sent and when the data was received from the server. It's a 5.8 megabyte load this time, and it took 3.1 seconds to generate. In a third case, we have a large data source, the same large data source with 30,000 objects. It's got the same deep data bindings as before, but now it's got filter dependencies, as you can see here. Taxitrip.taxi exists in taxis all. And you can see here, there's even more filter dependencies that aren't shown. Taxi trip is dependent on taxis, taxis is dependent on taxi driver, and taxi driver is dependent on taxi companies. So for taxi trip to be read, first taxi companies need to be read, and then taxi drivers, and then taxis, and then taxi trips. You can see from when the request was sent and when the response was received, it takes 3.7 seconds. So you can begin to see how it affects the loading time of your app when you load in the data for the first time. If you have no filter dependencies or no data bindings versus if you have both, it's nearly twice as long. And once all of your database connected data sources are populated, then it's time to calculate any function properties which may exist on all of these database connected data sources. So we'll go through a couple of examples. Case 1, as you can see below, it's a very simple function. We return the total amount and the payment type display name. For example, 32.1 cash. Both of these fields exist already on the taxi trip, so we're just putting them together. And this takes 0.09 seconds to run for all 30,000 objects in this data source. Case 2, however, is a bit more of an advanced function. We look up the first name of the taxi driver using the taxi driver all data source. So we actually read in a lot of other data into this function and then calculate the first name from there. And you can see here it takes 0.82 seconds to run for these 30,000 objects. So it's actually 9 times longer using this method. And then after the function properties are calculated, then it's time for the onUpload action to run, if there is one set for the app in question. If an app variable, for instance, which is used in filtering, is updated on upload, then the relevant data sources will be refiltered and the relevant function properties will be recalculated. As you can see from the example on the right, we have filtering on taxi trip 30,000, where pickup time is greater than or equal to app variables filter data start. And then we can see on upload, all we do is update that app variable, but we can see that we changed the date to 5 years ago. And this reads in a lot of objects, so this data source needs to be refiltered and all of these function properties need to be recalculated. So you can see from the log, you're only updating one app variable, and yet it takes 3.5 seconds to complete because the data source needs to be refiltered and the function properties need to be recalculated. Once the onUpload action is run, then it's time to display the default view to the user. If there's an onViewLoad action, then this is run as well. And if there's an onUploaded action, then this is run in parallel with the onViewLoad action. And then the default view is displayed, unless there's some navigation that occurs on upload, in which case the user is navigated to this view instead. So, you have an app or an action that runs slowly, but sometimes this isn't useful. Sometimes you need to go deeper and identify the bottleneck which is causing these performance issues. So now we're going to discuss methods that you can use to pinpoint exactly where the app is struggling. If it's an issue with the loading of data, for instance, it takes 10 seconds before the app is displayed. Maybe you could try a direct link to a different view on upload instead of the default view that you're currently using. If it takes the same amount of time, then it's a data issue. But if it's much quicker in this case, then it's an issue with the UI in the first view. Once you've identified it's a data loading issue, the next step is to identify the data source or the data sources that are contributing towards this slow loading. The best method in this case is to simply divide and conquer. Take half of the data sources and disable them. Does this have a significant impact or not? If it does, then it's likely the root cause of the issue is lying in those data sources that you disabled, and so you can narrow down the search and focus on those. And then if it has no impact, then the problematic data sources are in the second half, and you can narrow down the search in that half instead. Contributing factors to slow loading, as you can see from the list, too many records is the most problematic. If you're reading in huge amounts of data, then this will inevitably take a long time to load. It can also have an impact if there's a lot of records and function properties which are complex also need to be calculated for all of these records. Something that can have an impact but maybe less impactful is deep data bindings on these data sources, or exists in filtering, which causes filter dependencies. Maybe you have a problematic data source, but the problem isn't the amount of records, but it's a specific function property instead. So there's a property on a database connected data source, which is called initially skip function properties. And this allows you to simply load in the data without calculating these function properties. An alternative instead is to use console.log inside the function property to log when the function property began calculating and when it ended calculating. If you do this for all of the function properties, then you'll be able to quickly realize which of these take the longest time, and you'll be able to identify which function properties are causing these bottlenecks in your app, taking a long time to load. So now we found a bottleneck in our app which is causing these loading issues, and now it's time to discuss how we can actually fix the slow loading. It's often useful to create a debugging app by duplicating the app which is problematic. You can set the app type to config and admin, and then you can deploy to staging. In this case, you can debug without affecting the app itself, but you're also interacting with production data, which is a useful way to be able to replicate these performance issues. Something else to consider is quite simply reducing the number of records. Maybe you can take a look at the filtering on these data sources. Limit the filters even further so that it's only relevant data which is being read in. Maybe you have all of the orders from the last year, but maybe this could be limited to the last 3 months, the last week. Using the limit and skip settings on database connected data sources is often useful to be able to implement custom pagination. The limit property means you can have a maximum of, for example, 20 records in the data source at any one time. And the skip setting defines how many items you should skip before reading in. Lazy loading is also useful to think about. You can use the initially disabled flag, which we've discussed earlier, to disable these data sources which take a long time to load. And then you can enable these data sources again when the user navigates to a part of the app where this data is necessary. Or maybe you can make use of runtime-only data sources instead and read from the database on upload. Take a look at the function properties on your database connected data sources and consider if they're needed. You can remove them, for instance. Use find references and see where this function property is actually in use. Is it needed? Is it critical for the functionality of the app? Could the logic simply be deleted entirely? Or if it's only in use in one table in the app, maybe this function could be moved to the UI instead, so that it's just a function column on this table, which is a much more performant way of calculating the same data. Consider replacing these function properties. For instance, you can move it so that it's an actual property and persisted to the database and saved, and then make sure it's updated correctly and manually. For instance, case.hasDocuments. You can recalculate this every single time a case has a document added or removed, and then set the Boolean to true or false. If the function property is needed, then consider optimizing it instead. Take a look at the data which is read into this function property and where it comes from. And we can mention a few other tricks which can also help to fix slow loading. Reference data sources can be configured for each database connected data source. For instance, if you're referring to taxitrip.taxicompany.name, in a normal instance, the app would generate a new data source, which would hold taxitrip.taxicompany. But you can instead configure a reference data source. If all taxi company names can already be found in another data source, then configuring a reference data source is a useful way to avoid redundantly generating duplicate generated data sources. Consider denormalizing your data as well. For instance, if you have an employee which references a department, which references an office, which references a company, and you want to refer to the employee's company, then you have to go through 3 or 4 deep data bindings before you get to the company name, which is not performant at all. It may seem counterintuitive at first, but adding a company property onto employee and department and anywhere else that might have a deep data binding reference to company is actually a lot more performant, because this allows for faster access to filtered data, and it avoids filter dependencies using exists in. For example, order.company exists in all companies. It's a lot more performant to use, for example, order.company equals my company to filter directly on the company of the logged in user. The next part of the presentation will focus on performance issues that stem from specific user interactions, for example, creating, deleting, updating objects. If you receive the complaint, everything is slow from a customer, or you experience it yourself, try and think about, is it really everything that is slow, or is it certain aspects of the app? For example, navigation between views. Does it happen when you click a specific button? In which case, note down which views and buttons it is that are affected. Say the top 5 cases, and this is really useful to begin to start debugging actions. And then you can get to work. Look out for these action nodes, anything relating to CRUD operations or a selection of an object. For instance, setting selection on an object class can cause refiltering in other object classes if their filtering is dependent on this selection. Any update on a data source which is used in filtering will cause refiltering in the other dependent data sources as well. And the same can be said for creating, deleting, and persisting objects. Any change to an object class which is referenced in filtering will cause these data sources to be refiltered and their function properties to be recalculated. So let's have a look at some specific case-by-case examples. In case 1, we have a set selection action node. And as you can see from the logs, it takes 590 milliseconds to run, even though we're only selecting one object in taxi companies all. And you can see from the screenshot below, this is because taxi trip for selected company uses taxi companies all in its filtering. So any change in the selected objects in taxi companies all will cause refiltering in taxi trips for selected company. In the second case, we will simply be updating an app variable. But as you can see from the logs, this process again takes over 600 milliseconds. Even though you're only updating one app variable, the side effects of this update are strong. You can see that this app variable is used in a function property, which means that all function properties referring to this need to be recalculated. And it is also used in the filtering of taxi trip for app variable company, which means that this entire data source needs to be refiltered as well. In this case, we create and delete objects. As you can see from the logs, it takes 650 milliseconds to create the object and nearly 800 milliseconds to delete the object. As you can see from the action, after you create the object, we set the selection. So not only does this affect the function properties which refer to this, but it also affects the data source which uses this in its filtering. All of these function properties need to be recalculated, and this data source needs to be refiltered as well. And then when it comes to the deletion, again, as with the create, all of these function properties need to be recalculated, and this data source needs to be refiltered. So now you can think about everything we've discussed so far. Take a look at the function properties. Take a look for recalculations which take over 100 milliseconds. Can these function properties be removed, improved, or moved to the UI? Try and limit the number of data sources or the number of records that the app uses. Again, look out for side effects of processes that take over 100 milliseconds. Identify data sources that are being refiltered every time. If there are many different database-connected data sources in your app that refer to the same object class, maybe consider merging these or removing them. And take a look at the filtering as well. Can the same filtering be done without dependencies, or can the filtering even be improved so that less objects are read into the app? You can also try and reduce the usage of the set selection action node. Look out for these side effects, again, where it takes over 100 milliseconds, and consider, is the selection even necessary? Could you use object in context instead? Could you read objects? Could you use a function instead? If it really does feel like everything is sluggish in your app, then this can be due to chatty data sources which have subscribe to updates turned on. This is how it may look in the log with subscribe to updates. If local updates don't perform well, then the same performance will be experienced by other apps for other users. It is not recommended to use subscribe to updates in the case where it's a very commonly used data source. For example, if there's one request that comes in every second and all of the recalculations that need to be done every single time take 700 milliseconds, then your app spends 70% of the time just recalculating and refiltering over and over and over again. And then in this case, it's not surprising that the behavior can seem sluggish. You should also avoid using subscribe to updates in data sources where there are many filter dependencies, or there are many function properties, or the number of objects is large. In the final section of this webinar, we will discuss features that are available in Appfarm Create, which can help you improve the performance of your apps. First, some quick fixes. Initially disabled has already been discussed in this webinar. You can turn it on for any database-connected data source, and then it will not be read into the app on upload. Instead, you can turn off this data source attribute again later when the user navigates to an area of the app where they actually need access to this data, and then the data can be read in when it's needed. Initially skip function properties is another attribute which is available for database-connected data sources, and this means that function properties will not be calculated. This is a very useful attribute to keep in mind. If you have an action which involves a lot of CRUD and a lot of selecting, then it can be useful to enable this at the start of the action and then disable it at the end of the action. So then all of these function properties are only calculated once instead of every single time there is an update to this data source. Filtering has been a common theme. Look at your filtering and see if you can make the filtering even stricter so that even less objects are read into the app. Make sure that only data that the user actually needs is read into the app. For instance, if you read in cases from the last 2 years, but maybe the user only actually needs access to the ones from the last month, then maybe this filtering can be implemented. Maybe you read in all of the order lines which have status deleted. Do you need to read those in? Maybe you can add in some filtering. Reference data sources have also already been discussed. These can be set on database-connected data sources, and these tell the app where they can collect information from without redundantly generating these generated data sources. And this will help performance, as there will be less duplication and less generation of new data when the data actually already is loaded into the app. And then again, we go back to function properties. Maybe these can be removed, maybe these can be optimized, or maybe these can be moved so that they're only calculated in the UI instead of on every single object. And then we come to slightly more complex processes, which can be a lot more difficult to implement if you're optimizing an app that was built a few years ago, but they're still very useful to know and will help you to build even more performant apps in the future. Maybe instead of database-connected data sources, you could use a data connector. A data connector allows you to update, create, and delete objects directly to the database without reading anything into the app. This helps for making changes to data without having to worry about function properties being recalculated or other database-connected data sources being refiltered, as the changes are made directly to the database. Maybe instead of a database-connected data source, you can use a runtime-only data source. Here you can make many changes without worrying about recalculating of function properties or refiltering of data sources, as the changes aren't reflected in the database until they are persisted. So all of these changes can be persisted at the end of the action, and then all of the updates, all of the selects that you do in the running of the action will have less of an impact. Initially skip and limit are also very useful to think about. Maybe you have a table where only 50 objects are shown at any one time, then set the limit to 50. Then only 50 objects will be in this data source at any one time, instead of every single object. You can combine this with the initially skip object count property to make some custom pagination functionality. As previously mentioned as well, maybe you have several database-connected data sources which actually refer to the same object class, and they just have different filtering or different functionality. Consider if any of these can be merged so that they make use of the same data source instead of 2 or 3 different ones. Or maybe these can be removed entirely. Maybe they could be moved to runtime as discussed, or moved to a data connector as discussed. Reducing the number of database-connected data sources and the amount of data in each database-connected data source is a very effective way to improve performance. As previously mentioned too, consider denormalizing these function properties. Do they need to be recalculated every time the object is updated? Or could these be saved as a normal property in the database and then updated manually when needed? Consider using single cardinality data sources instead of many cardinality data sources when it comes to filtering. It is much easier and much more performant if filtering is done against a single cardinality data source instead of using exists in a many cardinality data source. For instance, you read one company into the app, which is my company, and then all of the filtering on orders can be done against my company. While most performance issues are related to data or other backend processes, it can also be useful to consider ways that performance can be improved from the UI perspective as well. For instance, maybe have a resource planning view where you have 500 employees and you can plan 3 months forward in time. That's a lot of data to generate. Maybe have an action which allocates a resource to a specific week, which involves a lot of creating of an allocation data source. If you have conditional styles on this view, then changes in the data while the action is running will require the UI to be re-rendered. This is where pause render and skip render can come in. These are action properties which can be turned on for any action. And this means that the UI will not be re-rendered while the action is running. Virtualization is also an important concept to consider. If you have an iterating container, which is a complex setup in the UI, which shows a lot of columns and a lot of rows, then you might notice some sluggish behavior as you're scrolling left and right or up and down. With virtualization, only the data that is shown on the screen is rendered by the UI, and other data is re-rendered and regenerated as the user scrolls. This is much more performant, as if you have a table with 5,000 employees, you're actually only generating 10 at a time and regenerating as you scroll, which is a much more performant solution in this case. And that brings us to the end of this Appfarm Developer Forum webinar. Thank you very much for watching.